If the difference in electronegativity is lower than about 0.5, the electrons are shared pretty equally and you get a nonpolar covalent bond. If it's bigger than 0.5 but smaller than around 1.7, one of the elements is pulling on the electrons pretty hard. Not quite hard enough to completely steal an electron, but definitely hard enough to skew the electrons a bit, making it a polar covalent bond. An example is water. Oxygen has a very high electronegativity compared to hydrogen. As a result, it pulls the electrons of hydrogen so hard that they kind of belong to oxygen, giving it a partial negative charge, and leaving hydrogen with a partial positive charge. The presence of two poles with opposite charge is called an electric dipole. All permanent dipole molecules can interact with each other, and really with anything that has a charge. As a result, the molecules will tug on each other and arrange themselves in a way that oppositely charged ends are next to each other. The forces acting between them are called intermolecular forces, or IMFs. A specific example is hydrogen bonds, where hydrogen bonds to something very electronegative, like fluorine, oxygen, or nitrogen, creating strong dipoles that tug on each other. But even if molecules are not polar at all, there can be electrostatic forces acting between them. How? Electrons move around inside the atoms, and by pure chance, they can end up on one side of the atom, creating a momentary dipole, which influences other particles next to it to become a dipole as well. At least for a very short time, as the electrons keep moving and the dipole disappears. This is called the van der Waals forces. The polarity of water also explains why it's one of the most versatile solvents to exist. It can pull apart molecules by tugging on charges, and it keeps them apart by surrounding a particle with its oppositely charged end. Water cannot dissolve nonpolar molecules though. It's the reason why water and oil don't mix, since fat molecules are nonpolar while water is polar.